All right, so in 1.5, we talked about complementary and supplementary angles. Supplementary means what? Add up to 180. Complementary, add up to 90. We talked about adjacent, which means what? They share a vertex and a side, but don't overlap, right? So they're like next to each other. We talked about vertical angles, which are the ones where if you extend the sides, it forms the other one, right? They make that kind of X. And we talked about linear pair, which is what?
We have two adjacent angles that add up to 180.
Good. So two adjacent angles that form a line, right? And then we know from there that they're supplementary, right? Okay, so number 1 says angle 1 and angle 2 are supplementary. If the measure of angle 1 is 97, find the measure of angle 2. What's the answer? 83. 83 degrees. Okay, subtract it from 180. Number 2, angle 3 and angle 4 are complementary. If the measure of angle 3 is 74, find the measure of angle 4. Chris. 16 degrees. Good. 3 is an example of a linear pair, right? Those two form a line, which means they add up to 180. So I can say 3x minus 6 plus 2x plus 16 equals 180. Combine my like terms. Subtract the 10. Nope. I think we've gotten this exact thing like 3 times, right? 34, right? 3, yeah. Okay, so x is 34, but the question asks for EFH. So I got to take that 34, plug it back in. 3 times 34 minus 6, 102 minus 6. Good. 96 degrees. Questions on any of those? We're good? Okay. All right, so this is 32. So, God bless you. I've got 2 types of angle pairs going on here. Who could give me one that they see? Nicholas. I've got a linear pair here on the right, so these two are going to add up to 180. What else do we see? Because there's a bunch of different things going on here. Claudia. The 3x would be a linear pair with the 5y plus 38. There's one more thing going on here. Vertical angles. And what do we know about vertical angles? They're the same. So you could do this a couple of different ways. Once I get the x, I can use the vertical angles, right? But I have to get x first, or I can get nowhere. I have 2 angles that have an x in them, and those are the linear pairs. So I'm going to say that 3x plus 8 plus x plus 26 equals 180, which means 11x. Subtract the 26 equals 154. And x is 14. Once I know that, I can either plug it in here and use the vertical angles, set them equal to each other, or I can plug that in here, so 3 times 14 plus 5y plus 38 would equal 180. So 42 plus 5y plus 38 would equal 180. 80. Subtract that 80. And divide by 5. Again, I could have plugged the 14 in here. I could have said 8 times 14 plus 26 equals 5y plus 38 and solved it that way. All right, 28. 2 angles form a linear pair. The measure of one angle is 4 times the measure of the other angle. Find the measure of each angle. So we're pulling the algebra skills back in here because we've got a word problem that we have to give variables to. So the first thing I know about them is that the first angle plus the second angle is a linear pair, which means what? It's going to add up to 180. The second thing it tells me is the measure of one angle is 4 times the measure of the other. So let's say the first one is the one we know nothing about. How would I show 4 times that? 4x. And I know they add up to 180. So 5x equals 180. 36. So it says find the measure of each angle. This is the first one, and the second one is 4 times that. And I can check it because what should be true about those two? They should add up to 180. Okay, and 30 said the measure of one angle is 24 greater than the measure of its complement. What are the measures of the angles? So there, we did an example like this yesterday. You're definitely going to see this again. Maybe not complement, but supplement. So you definitely want to understand this, and this is one people struggle with, okay? So if it says one angle is 24 degrees greater than the measure of its complement. So we can call that first angle x because we don't know anything about it. The second angle, how would I show the complement to x? Sarah?
X plus 24.
But before I even get the 24 in there, how do I show the complement to x? What's complement mean? 90 degrees. So if this is x, what's the complement? 90 minus x. So the complement to an angle, doesn't matter what the relationship is. In this case, it's 24 greater, but I'm not even there yet. If I talk about an angle and its complement, it's x and 90 minus x. If I talk about an angle and its supplement, it'd be x and what? 180 minus x. Does that make sense? So if you're a replacement, like with the words person, then the measure of its complement is 90 minus x. And the measure of one angle is my x. Okay? So now the relationship between them is that the first one is 24 degrees greater than the complement. How would I show 24 degrees greater than? Plus 24. So it's this plus 24 equals that. You could also have done x minus 24 equals 90 minus x, okay? But usually people favor the plus, the adding instead of the subtracting. So x equals 90 minus x plus 24. X equals 114 minus x. Add the x, 2x equals 114. Divide by 2. And x is 57. Okay, so now I know x, which is the first one, and I want to know both of them, which means how do I get the second one? I can plug it back in. So if the x was 54, then how would I find the complement? I'm sorry, 57. How do I find the complement to this angle? 90 minus 54. Or 57. Holy moly, I'll get it right at some point. Which is 33. So is this 24 more than that? Yes, that's how you check to make sure you did it right. Okay? So again, when you see the words an angle and a complement, the complement to an angle is 90 minus x. When you see the supplement to an angle, it's 180 minus x. So if the words throw you, as soon as you see those words, replace them. An angle and its complement would be 90 minus x. An angle and its supplement, the supplement would be 180 minus x. Standardized tests love these types of questions, okay? So it's good that you see them. Number 4, find the measure of angle ABC. So what's true about these two angles? That's a 90-degree angle. So they are going to be what? They're going to add up to 90 degrees, which means they're complementary. What else can you tell me about those two angles? What other special name do they have?
Linear?
Nope. Linear would be the form of a line. They're adjacent. Everybody sees that, right? Okay. So x plus 9 plus 2x equals 9. 3x would equal 81, and x would equal 27. Okay, that's the x. I take that. I want to find ABC. 27 plus 9, which is 36 degrees. And then number 5 says, is it possible to draw a figure that contains exactly one pair of vertical angles? Anybody figure it out? Is it possible? What happens if I make a pair of vertical angles? There's at least 2 other ones, right? Okay. Yep.
Do you have to have 2 lines?
To make a vertical angles, it's got to be 2 lines. And they have to crisscross, basically. They have to make that x. It's no. Yeah. So we're going to cover the concepts that you need to know for your test, and I'll work out some examples. Your homework is going to be the chapter review assignment, which I'll post the answers to. So there's no submission, okay? You can check your answers because on Tuesday like test time. So when you come in, you're going to get the test, so make sure we have the entire time to take the test. There won't be review time, okay? If you need extra help, then you need to you can email me over the weekend. I can try to communicate with you, okay? But I will be here early Tuesday morning if you need help. So we have a meeting at 7:20 on Tuesday morning. I'll be in the tech office at 7 Tuesday morning if you need the help, okay? All right. So identifying points, lines, and planes. I started each section with the definitions that you should know here. I'm not going to give you what is a point and a line, okay? So I don't need these word for word. But you would want to know these to be able to answer true or false about them, or to be able to identify stuff from a diagram, okay? So a point, you just need to really know that it's named by a letter, okay? It has no dimensions. It's the simplest shape, and it's named by one letter. Okay, we see it as a dot. A line has one dimension. Okay, it has two arrows. And we name it with two capital letters or one italicized letter or cursive letter. So this would be called line AB or line BA, the order doesn't matter, or line L. I think italicized is spelled wrong, isn't it? It's a constant reminder I teach math and not English. So can you measure a point? No. Can you measure a line?
No.
Can you find the middle of a line? Okay. Can't measure it, doesn't end, right? A plane has two dimensions. It has length and it has width. It never ends. No thickness. No edges. We show a plane as a tabletop or it almost looks like a parallelogram. That's the symbol for it, okay? But really, it never ends. Man, I hope your notes are cleaner than mine. All right. So it is named by one bolded letter or by three or more points that lie on the plane. So this would be plane M or A, B, C. Okay, what are collinear points? Madison. Points that lie on the same line. So it's not going to ask you define collinear points. It's going to ask you, based on this figure, give me 3 collinear points. What are coplanar points? Leah. Okay, endpoint would be a point at the end of a segment, or there's one endpoint on an array, okay? Okay, array is what? So Leah, what's array? Good. One endpoint, one arrow. And the order of the letters is important with array, not with a segment, not with a line, not with a plane, but they are important for the array. So if I was going to name this, which one gets the arrow? The B. So this would be ray A, B. Okay, whichever one is closest to the arrow, the other one's going to get the dot, right? So the other one would be the end point. What are opposite rays? Leah. Okay, two rays with the same endpoint. And they also have to point in opposite directions, right? Man. I'm going to get the hang of this thing eventually. What do two opposite rays form? A line. And an intersection is what? Sorry, go ahead, Chris, I didn't see you. Where two figures meet. So it could be two lines, it could be a line and a plane, it could be two planes, it could be two rays, it could be two segments. So again, it's not going to ask you, give me word to word a vocabulary definition, but you might get given a diagram and it might ask you, where is the intersection of this? Or you get a true or false question, like the intersection of two lines is a point. True or false? True. The intersection of a plane and a line is a point. The intersection of two planes, a line. Okay, so you want to know that kind of stuff. So you would want to be able to either fill in that blank or true or false. Questions that you're going to see from section 1 are, like I said, they're not going to be straight vocab. They're going to be either you get a diagram and you've got to answer questions on it, or true or false. Okay, so 1.2 is where we talked about the line segments and congruence, that kind of stuff. The coordinate is the numeric value assigned to a point. So if I had this along a line segment and this said A and this said 1, then my coordinate is 1. It's the numeric value. The distance between, in this case, we were just doing points on a number line. We weren't doing coordinates yet. The distance between 2 points was the length of the segment. Okay, so if it's on a number line, you can just count it. You're not going to get a number line. You're going to get distance formula problems. Congruent segments are segments with equal length. And then the segment addition postulate said if B lies between A and C, then AB plus BC equals AC. Does that mean that B is the midpoint? No, it just means the two would add up to give you the whole, okay? So for an example, with the segment addition postulate, it would look something like this. Given B lies between A and C, AB is 3x plus 10, BC is 2x plus 5, and AC is 30. If you need the visual, give it to yourself. So if B lies between A and C, B is somewhere in between, not necessarily the middle, but somewhere in between. AB is 3x plus 10, and BC is 2x plus 5, and the whole thing is 30. So I can take 3x plus 10 plus 2x plus 5, and I can add them together and set it equal to 30. So I'd get 5x plus 15 equals 30. Subtract the 15, 5x would equal 15. Divide by 5, and x is 3. And I can always plug this in. So 3 times 3 is 9, plus 10 is 19. And then 3 times 2 is 6, plus 5 is 11. 19 plus 11 is 30. So if you've got the extra time on your test, you can always go back to a question like that and check it. Okay, so 1, 3 is midpoint and distance formulas. From here, okay, you want to, of course, be able to define midpoint. So it's the point halfway between 2 points. Okay, you can only find the midpoint of a line segment. You can't find the midpoint of a line or array. The segment bisector is a line, ray, segment, plane, an object that intersects a segment at the midpoint. The midpoint formula when you're given 2 points is x1 plus x2 over 2 and y1 plus y2 over 2. And the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So an example you would see could be given M, or it'll say M is bisected at point M. So you'll see it two ways. Given M is the midpoint, or AB is bisected at point M. And AM is 2x plus 3, and MB is 4x plus 11. So again, if you want a visual, give yourself it. So AB and M is now the midpoint. So this is cut into two congruent parts. AM is 2x plus 3, and MB is 4x plus 11. So to solve this, I just set them equal to each other. 2x plus 3 equals 4x plus 11. Subtract the 2x and subtract the 11, and divide by 2. If this was the length of a segment, it couldn't be negative, but because we're just talking about the value of x, it can be negative. The answer can be negative. Okay, given A is through -3, 2, and B is 6, 8, find the midpoint and the length of AB. So for the midpoint, I'm going to say that this is x1, y1, x2, y2. Add the two x's, divide by 2, add the two y's, divide by 2. So I'd get 3 over 2 and 10 over 2, which becomes 3 over 2 and 5. And you can leave it as 3 over 2, or you can put that at 1 and 1/2. Either way it works. And then length, so the distance would equal x2, which is 6, minus x1, which is a -3, squared plus 8 minus 2 squared. This becomes plus 9 squared plus 6 squared, 81 plus 36, 117. And then I would see if I could break that down. This is actual divisible by 3, it'd be 3 and 39, which is 3 and 13, and that's prime. So the 3 can come out to the front because there's a pair of 3's, and I would get 3 root 13. Okay, M is the midpoint of AB. A is -3, 2, and M is 1, -4. Find the coordinates of B. So this time we've got a segment AB. We know the coordinates of A and of M. We don't know the coordinates of B. So this is where we split them up. So I would say that the x1 plus x2 over 2 equals the x coordinate of my midpoint, which is, and then the ym would equal y1 plus y2 over 2. So this is my x1, y1, and this is my xm, ym, because it's the coordinates of the midpoint. So xm is 1 equals x1, which is -3, plus x2 over 2. Multiply both sides by 2. Cancels here. I get 2 equals -3 plus x2. Add that 3, and x2 is 5. Same thing over here. Now we're talking about the y's. So the y coordinate of your midpoint is -4. y1 is 2. y2 is what I don't know. Divide by 2. Multiply by 2 on either side. -8 equals 2 plus y2, because the 2's have canceled here. Subtract that 2, and y2 equals -10. So 5, -10 are the coordinates of my other endpoint, which is B. Okay, now we're going to move into 1.4, which is measuring and classifying angles. So an angle is formed by 2 rays. Okay, an example would be something like this. The sides are rays, and the vertex is a point where the 2 rays meet. Congruent angles are angles that have the same measure. Angle bisector is a ray that cuts an angle in half. So if I had an angle drawn and I had a ray drawn, it could either say that this is the bisector, and then that's how you'd know it is, or it would be marked like this, where those two parts are congruent, or you could see something like 30 degrees and 30 degrees, and then you would know that that's an angle bisector. Then we talked about naming an angle. It's vertex and sides. So if the vertex is only shared by one angle, like in this case, then I can call this angle B. I could call it angle ABC or angle CBA. The vertex should always be in the middle. The sides are rays, so it would be ray BA and ray BC. And the vertex is a point. If that angle is now divided into 2 angles, no matter what the size of it is, I can no longer call that angle B. I'd have to call the big angle angle ABC, the top angle ABD or DBA, and the bottom angle DBC or CBD. Okay, there are 4 ways to classify an angle by its measure. An acute angle is less than 90 degrees. A right angle is equal to 90 degrees. An obtuse angle is greater than or in between 90. So greater than 90 and less than 180. And a straight angle is equal to 180 degrees. A straight angle is a line. Angle addition postulate says if B lies in the interior of angle say MNO. So we can get a visual on that. It would be angle MNO, and anywhere in here would be B. So I could say something like that. If that's the case, then angle MNB plus angle BNO would equal the whole angle, which is MNO. So if you were given part of it, like this says, if M is in the interior of angle ABC, so ABC, M is here, and angle ABM is 52 degrees, angle MBC is 48 degrees, find the measure of angle ABC. So angle addition postulate says just to add these two up. 52 plus 48 is 100. So ABC would be 100 degrees. The next one says, given ray BD bisects an angle. So angle bisector cuts an angle into two congruent parts. So if I've got A, B, C, and D is here, these are two congruent parts. It says ABD is 5x plus 10, and BDC, that should be DBC, is 10x plus 25. Find the measure of both angles. So if this is an angle bisector, they would be equal to each other. So I set them equal to each other, subtract the 5x, subtract the 25, divide by 5, and x is -3. And then it says find the measure of the angles. So if I were to plug this back in, and you're actually going to get a negative here, so this is a bad example, but the process is the same. -15 plus 10 would be -5, and then plug it back in here. 10 times -3 plus 25, -30 plus 25, which would be -5. So they still match, but they should be negative. Okay, this one says construct an angle that's 35 degrees. So you're going to want to know how to use a protractor for this. My advice would be to either practice with the one on your iPad, or if you have one, I will have a class set ready for you for the test. But I would start with a line and then bring in a protractor. So I brought in a protractor. I would line the bottom up to the edge of my line. And in this case, find 135. And 135 is obtuse, so I know to use the bigger line on the bottom. And then just simply connect that angle so that I can make my 135 degree angle. Okay, number 1.5 says describe angle pair relationships. So now we're talking about complementary, supplementary, adjacent, linear pair, and vertical angles. And this is how we started the day. So complementary is two angles that sum to 90. Supplementary, two angles that sum to 180. Adjacent is angles that share a vertex and a side without overlapping. So these two angles, angle ABC and CBD, are adjacent angles. Linear pair are angles that form a straight line. So something like this, angle 1 and angle 2 would be a linear pair. And vertical angles, the sides of one can be extended to form the other. So vertical angles would be like angle 1 and angle 2, the vertical angles, and then the other two, angle 3 and angle 4, would also be vertical angles. Okay, so this is an example using that. So given A is 63 degrees, find the complement to A and the supplement. So if A is 63 and we're talking complement, we would do 90 minus 63. And I would get 27 degrees. That would be the complement. And then supplement 180 minus 63. And it's 117. That would be the supplement. The next one says angle A and angle B form a linear pair. So I've got two angles, A and B. Angle A is 5x plus 20, and angle B is x minus 14. So because they form a linear pair, I know they're supplementary. So 5x plus 20 plus x minus 14 equals 180. 6x plus 6 would equal 180. Subtract the 6, 174. And x would be 29. Take that, plug it back in to get the angle. So 5 times 29 plus 20 is 45. 145 plus 20, 165. That's angle A. And angle B, there's two ways to get it. One is plug it in here, 29 minus 14, which is 15. The other way is that angles A and B should add up to 180. So if I subtract the 165 from 180, I should get the 15. And that's a good way to check them. Okay, an angle is 20 more than its complement, find both measures. So we talked about this at the start of class. If I'm talking about an angle that I don't know, that's x. Its complement would be 90 minus x. And the relationship here is that angle x is 20 more than its complement. So x equals